Good morning, everyone. I'd like to do a quick sound check here, and in either the chat or the Q&A. If you hear me okay, can you simply respond with yes or something? Let's see. Okay, very good. Thank you, Asreth. It is 7 o'clock, so let's go ahead and get started. This is a webinar from Frontline Systems, and what we're going to cover is Monte Carlo risk analysis using Monte Carlo simulation. And we'll be talking about two of Frontline Systems software tools, Analytic Solver for Excel and RASON, which is our cloud platform running on Azure. We'll spend the majority of the time really on Analytic Solver in Excel, because most of the people who attend these webinars are familiar with modeling in Excel and are interested in how much more you can do for something like Monte Carlo simulation. But we'll also spend a fair amount of time on RASON, and the heart of this is around the idea of, okay, you've built a great analytic model and the results are of value to like people in your organization. And then the issue is, how do you share those results with others? And there are situations where, running on your own computer locally is fine, and people looking over your shoulder, that's how you share results. There are situations where you end up making a presentation, and during the presentation, you put some results onto a PowerPoint slide, or maybe even show your desktop Excel live. That is sometimes sufficient. But there are plenty of other situations where a wider range of people need to see the results of the model. They might be remote from you and in different departments or organizations, not so easy for them to find out from you just through a meeting or over the shoulder. And you might need to do this on an ongoing basis, as you might want to resolve the model, rerun the model every week or every day, and share the latest results. So that's what we enable with the tool we call RASON. Okay, so here's the sort of general outline for the major topics we'll cover. We're going to start talking about modeling and solving risk analysis problems involving uncertainty, essentially, using Monte Carlo simulation in Excel. And there we'll be using Analytic Solver Desktop, which will run in Excel for Windows. We'll also demo Analytic Solver Cloud version, which runs in a browser, and will actually also run in Excel for Windows and Excel for Macintosh, Excel for the web. And Frontline's a bit unique in this respect, that when you get a license for Analytic Solver, you get both. That is, you get Analytic Solver Desktop and Analytic Solver Cloud, and you can use them pretty much interchangeably. After talking some about Monte Carlo simulation and some things you can do, we'll then turn to the topic of deploying your simulation models, that is, making the results of those models available to others, even the ability to run the model live. And we'll, if possible, we'll certainly take a look at RASON, and if possible, take a look at Power BI, as well as a deployment vehicle. So we'll be talking about these two major products. Analytic Solver, you can see on the left, is obviously in running essentially as an add-in to Microsoft Excel. It's a very powerful add-in. And over on the right, running in a browser, that's what's being pictured is the website rason.com. We're logged in, and rason.com is actually just a front end to a back-end web service or cloud service, which actually lives at rason.net. And these two products work together very closely. For example, over on the left, If you look at the dialog in the middle that's being displayed by Analytic Solver, it says manage models on the RASON server. That's something you can do. You can publish your models and track how they're run and track different versions of them and so on. So let's dig in now to setting up a simulation model in Excel. What's involved? There are some simple steps, and let's first just outline the steps. First step is just to create a regular spreadsheet model, a what-if model that calculates some outputs of interest for given inputs. I'm going to go ahead and show you that right away here with this simple yield management model. And I'm going to start, let me just start in the Home tab here instead of on the Analytic Solver tab with the ribbon. So in this model, the heart of the model is just right here. And what we're dealing with is the problem that an airline faces when a flight takes off and some of the passengers who book seats are no-shows. They don't show up the gate. And if the airline doesn't do something, the flight will take off with empty seats. And if you are the airline, that's actually a pretty big problem. It's like perishable inventory. It's like the apples that went bad. You cannot ever sell them. The seats that were empty when you took off, you can't recover that in any way. So that led the airlines to this idea of overbooking, and many of us have experienced this. When you overbook a flight, like for example, if this flight has 100 seats, if we sell 110 tickets, then see what happened in this particular scenario is we had 8 no-shows. So we actually had 102 customers show up, 110 minus 8. And that meant we had 2 people we had to bump, and we had to pay them overbooking compensation. So that's essentially what this model calculates. And it is a what-if model. If we just change the numbers like I just did in here, you will, you'll see different results. That is the first step. Okay, but now let's go back to PowerPoint for 1 second and say what's next. So the next step is to figure out what inputs in the model are uncertain, and then how are you going to model that uncertainty? So going back to Excel here for a minute, our number of no-shows is the key uncertainty in this model. We know what the ticket price is. We know what the number of seats are. We can control. As a decision maker, we can determine how many tickets we sell and that sort of thing. But the no-shows is the number of people. The number is the quantity that's uncertain. So we model that with a probability distribution, and we're going to dig into this in a minute. But right now, I'm just going to double-click this cell, and Analytic Solver will display the probability distribution that I'm using. This is called a log normal distribution. It never goes below 0. The number of no-shows does not go below 0. And it can go to 10 or 20 or in extreme cases even 30. This is more than the usual real airline situation, we hope, for a 100-seat flight. But it gives us an example to work with. So now we're going to dig in a little bit more to how you would choose that probability distribution and its parameters. Now let's go back to PowerPoint again. So all right, we've identified uncertain inputs. Now the model's calculating something. It's a what-if model. So we want to tell the software, Analytic Solver, that there's some certain outputs that we want to record. And here, the key output is this one, total revenue. We want to know, so in this particular instance, you can think of every time this model recalculates is equivalent to simulating the flight taking off 1 time. Okay, and so in this particular case, the flight earned 20,600 of revenue. That's because we had a lot of no-shows. We didn't fill all the seats. We oversold some of the seats, but we ended up with that much revenue. And if I just press F9, that will generate another sample from this distribution. This time we had 5 no-shows, 20,250, and so on. And if we do this enough times, we'll see the various outcomes that can occur. Notice, by the way, that generally we're getting something like 20,000 here by overselling the flight. If we only sell 100 tickets for 100 seats, look at this. This one's 18,900, 18,400, 18,600. You see, we generally do worse if we're the airline if we do not oversell the flight. Okay, back to PowerPoint. All right, so we select the outputs. Now what we want really is we don't want to manually press F9 over and over again. We want the software to run those trials for us. And by default, we run 1,000 trials, but you can easily run 10,000 trials. And then record all those outputs and then show us the results in the form of statistics and charts. Typically, that's what we want to see. Okay, back to Excel here. So now we've just been working on the Home tab of the ribbon and the only thing that's unique to Analytic Solver that's in this model is this if you can see this on the address bar, psi log normal, and then a couple formulas for the mean and variance of the mean and standard deviation of the log normal distribution. So now let's go to Analytic Solver on the ribbon. I'm going to spend just a minute here introducing what's available. You can see that there's a whole tab on the ribbon with a whole lot of buttons. And by the way, Analytic Solver includes its second tab on the ribbon, which has a whole set of features for data mining and machine learning, also for traditional forecasting. Right now, we'll just focus over here on Analytic Solver on the ribbon. And let's actually start right here on the Model tab. There's some very advanced options here, which we won't get into. But if I just click on the button itself, it opens this tab on this pane, the task pane on the right. And this shows us that we have this what if model here, but in cell H27, that's the same one we were looking at before, we have a probability distribution. That's an uncertain input. And then in cell G38, we have a output that we're looking at here. And actually, G36 contains revenue, and G38, let's look at that, contains a function that says psi mean of G36. And that means at the end of the simulation, this cell will show us the average of this cell, the average total revenue, over 1,000 different trials. Okay, so we've displayed that model tab, and of course there's the task pane, and there's other tabs on here. We'll talk about it in a minute. In this group, the simulation model group, this is how you go about defining, point and click options. Like, for example, it's how you would define this log normal distribution. And if we click on the button, we get a lot of choices for lots of different. Here's the log normal, here's uniform, here's beta gamma, here's the regular traditional normal distribution, Weibull, and so on, and lots more, and lots more. And these are discrete distributions that have, just integer or discrete values, and custom distributions. So there's a lot of choices here. And one of the ways, if you aren't sure, how to choose a distribution, there is this distribution wizard, which will start asking you a set of questions. Like if you don't have historical data, then it's going to give you some ideas, and it's going to start asking whether it's discrete or continuous, and then it's going to ask you about bounds, and then it's going to show you a narrowed down list of choices. Now, another thing that's pretty common is that you have some historical data for the uncertainty. So maybe like your uncertainty is interest rates or exchange rates. Well, that you don't control that, it's uncertain, but you do have historical data for, let's say, the US dollar euro exchange rate or treasury bond interest rates or something like that. Well, you can use that historical data to help you choose a distribution. You choose a distribution that fits that historical data. So we've got some historical data on no-shows over here. So let's go ahead, and I'm just using Control-Shift-Down to select, I think I've got 150 different observations in the historical data. So I just selected that cell range, and I go to this tool on the ribbon called Fit, and it gives me some choices. But basically, we're going to fit distributions, different distributions from this list we have over here. I'm going to actually use the Anderson-Darling statistics instead of AIC and BIC as the criterion for, how well does this distribution fit the data. So let's go ahead and run that. And now we have, you notice we have a whole ranked set of probability distributions. Log normal, inverse Gaussian, gamma, Erlang, etc. All of these distributions fit the data to some degree. For example, if I click on gamma here, the orangish line is the gamma distribution. It doesn't fit quite as well as log normal. If we were to use it, these are the parameters we would use for this distribution. You can see right now that the best fitting distribution is this log normal with parameters that are about 10 for the mean and about 6 something for the standard deviation. We're going to come back to that in a minute. these are alternative distributions of the goodness of fit. If you have the statistical background, you can appreciate that. But you would close this dialog and then say, do you want to accept this fitted distribution? If you say yes, then you drop it in a cell. We'll just put it here for a minute. And now you have exactly that distribution. Okay, and you can see on the address bar, we got psi log normal with 10.7 something and 6.4 roughly, and so on. But now let's think about this for a minute. In the real world, this uncertainty of the number of no-shows, is it really going to be a constant number no matter what we do in terms of number of tickets sold? If you think about that for a minute, you probably conclude, no, actually, if we sell more tickets, we're going to get more no-shows. And if we sell fewer tickets, we're going to get fewer no-shows. It's all going to be uncertain. It's all going to, in any given instance, we get a few or a lot. But overall, on average, for example, like the mean of the distribution, if we sell more tickets, the mean should be higher, should be bigger. So what we're actually doing in this cell here, if we look at what's in the, well, the simpler way actually is to look on the address bar here. We're saying psi log normal of 0.1 times G32, that's the number of tickets sold, and 0.006 times G32, the number of tickets sold. So we've actually refined the model a little bit from what just fitting historical data. And now when we go to oversell the flight, let's say 110 tickets, we're going to correctly project that we're going to get more no-shows on typical times the flight takes off. Okay, well, it's about time to run a simulation, right? We haven't done that yet. So what's going to happen is over here on optimization model and trials for simulation. Now, I do need to set this back. I'm going to run just one simulation to start, and then we're going to run it with 1,000 trials. That's the usual default. Glad I checked that. And now let's go ahead and run it. Now, you can think of this as just like F9, 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 right? Recalculating the model over and over again. But we're going to do that 1,000 times when we click Simulate Run Once. And so it just ran those 1,000 trials. And now what it's displaying by default is this uncertain function, G36, and that's revenue. And what we've seen here now is a distribution of revenue. You can see that in some cases, when we're selling 110 tickets, overselling the flight, our revenue can be as low as 18,000. In some cases, it can be as high as 21,000. Its average, its mean is 20,442. That same number appears on the spreadsheet because we have that psi mean function there. And we can see there's the maximum and the minimum. And here we can look at percentiles, like this tells us that the worst case, the bottom 1% of outcomes is around 18,600. The best case is 21,000, and so on. That's related to the number of tickets sold. And this chart tells us a lot of other things. Remember, we're just looking at the results of doing this simulation 1,000 times. By the way, there's various chart options here and axis options and so forth that you can use, chart type. Go back to statistics. So on other tabs here, we show this is the frequency distribution. So the bars indicate, for these particular levels of revenue, how often that happened. 5% of the time, 10% of the time, and so on. These red bars actually show you the 5th and 95th percentiles. And then we have other displays here, like this is the cumulative form of that same distribution. This is the reverse cumulative. This shows us sensitivity. If we had multiple uncertain inputs, this would be a chart with multiple bars, and the top bar would be the widest and lower bars would be narrower. So it's called a tornado chart. This basically is telling us right now that more no-shows means less revenue, right? We're negatively correlated in terms of more no-shows is bad for us. And then this is a scatter plot this is going to be interesting as we get further into this. So we have number of no-shows on the horizontal axis and revenue on the top axis. And there's an interesting thing about this chart is that revenue actually increases for the first 10 no-shows, and then it decreases. And why is that? Well, if you look at here, we're overselling the flight by 10. And what'll happen, given these parameters, is that we'll have cases where we get, 1, 2, 3, 4, up to 10 no-shows, and we fill those seats, and we actually, because no-shows get a 50% refund, not a 100% refund, we actually capture some revenue from the people who were no-shows, and we capture revenue from the people who filled those seats. Okay, so we're hopefully we're getting some intuition right away about how this situation in the real world will behave for us. Now, there's a few things we might want to do. Like we've tried 110 tickets sold. We might try 105, and we could then run another simulation. It's pretty fast, and it'll come up and show us, well, now it's 19,909. That doesn't look as good as an average outcome, and the maximum and minimum are, well, they're actually not as good either. So that might tell us something, but let's do this. Let's make the computer do the work here, right? So what I'm going to do now is I'm going to run what we call a parameterized simulation. The number of tickets sold, we're going to make that a parameter. We're going to run different simulations, and on each simulation, we're going to use it. We're going to ask the software to insert a different number of tickets sold. So the way you do that, so right now it's just 105 as a number. You're going to insert something in this cell. So we go to parameters simulation, and let's run this from 100 tickets sold to 150 tickets sold, and by default, I'll tell you how the stepping works from 100 up to 150. Now, in order to get all the values of 100, 101, 102, 103, and so on, that's 51 different simulations that we want the software to run. So we can ask for that over here. That's where it was set up initially. Run me 51 simulations. And while we're at it, why don't we just to show what the software can do? We previously ran 1,000 trials, 1,000 calculations of the worksheet. This time we're going to run 10,000 trials, but we're going to do all of that 51 times. So that is 510,000 trials, right? So let's see how long that takes. Simulate, run once, and we're done. And we have all 51 simulations here. You can see we're looking at the last one, simulation number 51. But here is simulation number 40. Here is simulation number 33. And all the way back to simulation number 1 when we were selling 100 tickets. Simulation 51, we're selling 150 tickets. And there's lots more we can do once we have this. For example, I'll go ahead and say that. I can go to charts and run and see charts across multiple simulations. And I'd like to see that in the form of a trend chart with all the simulations. And then I get something like this, which is going to show me the blue line in the middle is the mean, like psi mean of all these instances, and the gray area is the 75th percentile band, and green is the 90th percentile band. And you can actually open something over here to adjust those. But we can get a fair amount of insight here. And notice something, that revenue is increasing as we oversell the flight up into somewhere in this range, a little above 110, 12, 14, maybe 120, something like that. So that's pretty interesting. That's beginning to help us figure out how to make maybe this decision. But why don't we just ask the computer to make that decision for us too? I mean, why do we have to eyeball it? So what we're going to do now is just we're going to delete this sci-simprem function there and just put a number back in there. Okay, and now we're going to actually ask the software to find us the optimal number of tickets sold. So now we're going to use optimization as well as simulation. And what do we have to do? Well, the simulation model is already defined. We don't have to do any extra work there. In Analytic Solver, all these things are deeply integrated. All we have to do is say, this number of tickets sold is a decision variable, so choose decisions normal. And now over here on the ribbon, there's an optimization decision variable that's been selected, G32. And then what we want to maximize is our expected total revenue. That is the mean revenue across all 1,000 trials and so on, okay? So I pick this cell and say objective, maximize normal. That's all we need to do. Now it's a simulation optimization model. The objective is here, the variables are here. I want to go back and change and say, well, each time the optimization is run, we're going to run one simulation, and let's say 1,000 trials is enough for each exploratory move that the optimizer makes. And also check over here to say, so this is a nonlinear model, we're going to use the nonlinear optimizer. Now we just say optimize, solve complete problem, and we get this message because I'm in auto help mode. This is coming from what we call guided mode, but basically we have a good solution. And you see it's about, rounding up, it's 117 tickets sold yields us the maximum expected revenue, okay, across all those trials. And that's consistent with what we were seeing in the trend chart where we saw where that peak was. Okay, let me pause for a minute here and just see if we have questions. Okay. I just want to know, but okay, recording of this webinar will be available afterwards. Yes, that's this webinar is being recorded, and you'll be able to access the recording. You'll get an email basically with a link to the recording. I think that's all the questions we have right now. Okay, one further comment I just want to make is that we're looking at a model that has only one uncertainty in it. Well, you can imagine you might have the question like, okay, what if I had 30 uncertainties or something like that? That's straightforward. You just can insert these probability distribution functions like psi normal or psi log normal into a variety of cells and use them in your model. Here's another example model. This is actually projecting the growth of a college fund that is invested in the stock market. And so like here, for example, we have a normal distribution, and then each one of these cells for 24 years also has a normal distribution, and all of those are sampled. You can see, like again, if I hit F9, all these things are changing on every trial. And so when you run a simulation on a model like this, then it's taking into effect the fact that that we're sampling from the every year the stock market return is uncertain. Okay, well, this is great. So now we've seen how we can work with a model of this kind. I do want to go back to the original version of this model so that I don't complicate matters. So what I'm going to do is open a blank workbook, close this one, and then reopen that one. Okay. And we want, of course, this model. So now I'm going to turn to the topic of, okay, we've got this model, and we're getting some useful results, but how do we make these results available to others? How do we communicate these results to others? So now we're going to just talk about a facility that's actually available in the Analytic Solver. As you can see, this is something you don't have to use. You can do all your analysis in desktop Excel without ever worrying about a cloud service. But if you do want to make the results of this model available to others, you can do so with this Create App option. And you can see there's quite a range of options here: Power BI, Tableau, Solver SDK, and so on. Now, what are we talking about here? This might be unfamiliar ground for some of you. So a little bit of an explanatory slide here. So you're all attending this webinar through by means of a web browser. And that web browser is talking to a web server that's maintained by GoToWebinar. And my computer here, my browser actually is also talking to the GoToWebinar web server. And it's capturing what's on my screen and displaying it to you folks. So so GoToWebinar is kind of an example of a cloud service or a web-based service. And the way that basically works is over here, this is on your own computer, you have a web browser. I think everybody's familiar with that. And then over here, somewhere on some computer somewhere else, there is a web server. It simply is a computer that's running all the time, and it's connected to the internet just like yours is. It's perfectly possible, by the way, for your own desktop computer to run a web server. But typically these are web servers that are running in, there's banks and banks of the CPUs on racks in a big facility that's, that's air conditioned and security controlled and so on. But how does that actually work? Well, the browser, first of all, it's all based on communication over the internet, bits being sent back and forth. And for the most common kind of communication, there's an underlying protocol called the Internet Protocol, IP. You've probably heard of an IP address. And then layered on top of that, there is a protocol that you've also probably heard of called HTTP, Hypertext Transfer Protocol. And the secure version of that, which encrypts the messages going back and forth, is HTTPS. So that's what you see in your browser. If we're like here, this is actually Excel for the web, and we're looking at, we're talking to this server at solver1mysharepoint.com. That's actually a Microsoft server on Azure, and that's, we're talking to that through Chrome, regular Chrome web browser here. Okay, so through HTTPS, there are some commands that the browser can, or requests, you could really say that the browser can send to the server, like get, post, and put. Get is the command that basically says, just get me this web page. I'm going to send me the contents of that page back, typically in HTML, hypertext markup language, and CSS cascading style sheets, and then I'll render it in front on the screen for my user here. A post is used when typically when you fill out a form, that's being displayed for you on the browser. So there's a rendered page, it's a form, you're filling in some, your name or email address or numbers or something on that form, and then when you click submit, then the browser sends this command or request, a post request to the server, and in the body of the message being sent are the values of those form fields. And put is actually used to update things that were previously sent. So that's how a web server works. But now let's just imagine that instead of simply a browser here, we had some other program. Maybe a program that we write, a custom application. Maybe, there's a lot of things we could do here. And this custom application could run on a desktop computer, but it could also run in a mobile phone. In fact, virtually every app that you have in your mobile phone is doing this. It's acting a lot like a web browser, but it's a custom program, and it's making requests to a back-end web server and getting responses from it. So let's expand this whole view here. This is actually what we're doing with RASON. So RASON is a cloud-based server, cluster of servers running on Azure, and it's capable of servicing a wide range of like web applications or browser-based applications or mobile apps. We have some customers who have created their own mobile apps that are talking to the RASON server to run simulations or solve optimization models. And then Microsoft's tools like Power Apps and Power BI are also web-based and mobile, both apps that can talk to the RASON server conveniently. It's especially convenient. So that's what's going on when we talk to the RASON server. And something we just got a glimpse of a moment ago was actually Analytic Solver running in Excel for the web in a browser. So here's desktop. See, this is desktop Excel for Windows. But now, see, I'm going to Chrome, and I'm bringing up a web browser. And over here, for example, is just a web page on solver.com. And here's a tab that is open to a website running Excel for the web from Microsoft. And so here, for example, is the starting point for Excel for the web, and I just opened this workbook from my collection of available workbooks. Notice it's exactly the same workbook that I had on the desktop, and you can move these things back and forth. You can have the workbook on OneDrive, or you can have it on SharePoint. And when you're using the browser-based version of Excel for the web, you would add Analytic Solver to it. You wouldn't run a setup program or anything, but you would go over here to insert Office add-ins, and you have access to a whole, the Microsoft Store app source. But we've already got Analytic Solver already inserted here. So then we just go to The Analytic Solver tab in the ribbon looks very much like the one in Excel for Windows. We can open this, the task pane, and we can see the same kinds of things here. We've got this here, you actually can't double click in Excel for the web and have this pop up, but you can double click over here. And now I have to check out my license from use on the desktop to use it on the web. So I'll do that. And now I get this distribution, log normal distribution in the browser. Okay, so now what's happening here is that Excel for the web is running. An Office add-in that we developed called Analytic Solver Cloud version is running inside Excel for the web. And when it just comes to like displaying messages and so on, we're talking through Excel to you as you use this. But when you want to actually run a simulation, like let's do that now, let's just run a simulation of this model. So it said simulating solver has completed the simulation. How's that happening? It's not happening in your browser. And, you know, your browser is just displaying things. So how did it actually run the simulation? Well, it made a request, a REST API request, you know, with that get and post and put to the backend RASON server. And the RASON server actually ran the simulation for us and gave us these results. Okay, let me just check on questions here. All right, I got some, let's see. How many iterations or would be Monte Carlo trials would be necessary for an accurate simulation? It's a good question. There are some tools to help you figure that out. But I would say as a rule of thumb that in most practical, the reason the default is 1,000 is that that's usually enough. For some financial models that, you know, like if you're calculating exact values of derivatives where you're going to have a large position in those derivatives, then you might need a lot more trials. Let's see. How do we know which distribution should be assigned? Yeah, and that's hopefully I addressed that, but I would encourage you to use the distribution wizard in that case. And so coming back here to Excel for the web, going back to distributions and choosing this wizard, and the first thing it asks you is if you have historical data, it'll then say, okay, tell us where it is, because now we can help you fit a distribution to that data. And then if you don't have data, then it's got, then it has some examples. So here's kind of a direct answer to that question, which is in the software. Consult the literature for your industry, of course. For example, a common case is failure analysis of an electrical part or a machine on a production line. And that's like a Weibull distribution is often used. It's not the only one that can be used in that case. Poisson distributions are often used when you're simulating a queue or you're waiting in line for things and that sort of thing. And so I'll make a note here of the past proceedings of the Winter Simulation Conference. And if you go to wintersim.org, there's just a rich set of information in there. In our reference guide, there's a lot of information in there. And just to show you how to find that, if you go to help here, you can say help user guides, and you can get the whole works here. The Analytic Solver user guide, for example. I'll click it here, and I think this is we're gonna download 10.5 megabytes of PDF files, or PDF from the web here, and now you can there's a great deal in here. And what I want to come to, so here are a set of examples of simulation and risk analysis. Examples where we're using optimization with uncertainty, and lots more. Here's where we're covering parameters and sensitivity analysis. We use the simulation parameter, and then this is a very useful chapter: getting results in simulation when things go right, when things go wrong, and so on. And then at the very end, automated simulation VBA, do that differently in the cloud. And then here's the whole essentially tutorial section on on the concepts of, like types of distributions and dependence and correlation and so on. So you're welcome to look for that. And by the way, you can, if you are logging in, as you probably are right now, to solver.com because you signed up for this webinar, you can go into solver.com and just download copies of these user guides. All right, I think that's, let's see. Just looking for more questions here for a minute. Yes, best practices, lessons learned from others, yes. Okay, I think I've answered the questions I can right now. So let me come back to PowerPoint for a minute here. And let's, now we're going to build up a rather elaborate slide that Dr. Seema Maleki prepared earlier, but she's trying to illustrate here all the things that the RASON server is doing. And you can see here it's talking to Excel for the web, it's talking to, it can talk to browsers and to mobile apps and that sort of thing. So now let's try to dig into this. Now we're interested in the idea of, let's see if we can't turn our desktop Excel model into something that would actually run on the web or run in the cloud. So how do we do that? Well, I said you could go to Create App. So let's go ahead and try that. And we'll try, let's see, let's do a quick test first. And by the way, if you're puzzled in this, there's another wizard. Go to the wizard and it'll take you through a bunch of steps and you can say, I'm completely new to this. Can you show me a quick test, or I want to run my model in Power BI, and it'll take you through a whole discussion of that and kind of point out what the options are. Right now, let's just go to quick test and see RASON model. And now what's happening? Well, a browser tab opens at rason.com. I'm already logged into rason.com, but it knows how to log you in. And something appears in a window here, and you can see that it has something to do with the model that I have in Excel. And in fact, this is now a definition in the RASON modeling language, exactly corresponding to that model that we had in Excel. And looks like we're actually going to run multiple. We're going to run 51 simulations, 10,000 trials. So this is the parameterized simulation model. And that's all defined in this form. Now, what is this? This is a body that we can send in a HTTP post message to the RASON server, and it will respond not by giving us a web page to display. It will respond by actually running this model and returning results in this same form. And this form is called JSON, JavaScript Object Notation. I'm actually asking for 510,000 trials, but let's go ahead and try it anyway. So a single HTTPS post to the server, and let it run. And hope it'll finish. And given how much I'm in there, it came back. So I did run like all 510,000 trials, and so I got a lot of results back. But this came back from the RASON server, just like that. Okay. Now you would consume that in some program that you wrote that would display something of value in your application situation to users of your app. That would, now to do that would require some web development skills. And we understand not everyone has those web development skills themselves, but part of what we're showing here is that if you like, for example, can work with a web developer, this gives them something very easy to work with. And to show that in an even more dramatic way, this time I'm going to do a quick test web page. And all we're doing here is creating one file, which will save on the local computer, which will have an extension .html. So it's a single web page. And now what happened is Windows, seeing a new file, extension .html, opened it in the default browser. This is actually Edge. And you'll see that there's some kind of display here. It looks like we're again displaying the model, Scilog normal, scimprem, and so on. And down here we have some options. And in fact, we can say quick solve. And I think this will work. Let's see, we're doing a solve rather than a simulate. It'll take a little bit of time. But since it worked in rason.com, it should work here too. It may come there. It did work. Okay. And so it produced a result which we're displaying here. And what actually happened there. Now I'm going to dig in a little more deeply. I'm hoping that some people in the past have ever looked at the contents of a web page. This is the display in the browser. Let's say view page source. Okay, so it's HTML, and then this is the head and meta tags and so on, and then right here we drop into JavaScript, which you can do in the middle of any web page. And now we have something about RASON, and then starting right here, we have that same model, and you can sort of recognize in here that inside of the quotes there's scilog normal and sci-sim-param and formulas and so on in Excel. Well, that is your model, and that will be transmitted to the backend RASON server. And that actually happens right here. This JavaScript function gets executed when you clicked that button, this one right here. And so what does this function do? It goes to this constant, this .rason model. Well, that's this thing right here. And from here to the closing brace here. That, as far as JavaScript is concerned, is just one big structured constant. And JavaScript doesn't need to understand what's inside it, but just a constant. But it's valid JSON, JavaScript object notation. And so we can take that object and we can make it the data that we're passing in this post request to the server. This is now an AJAX call that we're making, asynchronous JavaScript call to the RASON server at this endpoint API solve. And then this code essentially says, when we get a response from this RASON server, from this request, run this function. And then run this function if it fails. What is quick status? It's right in a very short function. It simply takes the result that we got from the web server and puts it into this edit box at the bottom of the screen. And that's it. That's all there is to it. That's sort of how it works, is I'm trying to show you something at that kind of level. Okay, so hopefully, now I'm going to try to do something a little more ambitious, show you what further you can do. Like if you're not yourself a web developer, you don't have access to someone who is a web developer, but if your organization uses something like Power BI, then you can do this same sort of thing without writing any code. And the only problem with doing this is it will take a couple of minutes to run this. It runs certain tools on your desktop. But what will happen is, create app, Power BI, there are a couple of options here, managed model and embedded model, will create something like this web page here, but it will actually contain a whole wrapper of code specified by Microsoft, JavaScript code, that defines what Power BI understands as something called a custom visual. Okay, now I've done that already, and so let me go here back into another browser, and I'm in Power BI here. So I'm in the web version of Power BI, and I have a little workbook here. I should be able to do this again. I'll just go into edit mode, remove this, say remove, and so this is a Power BI dashboard, as it's called, and I've got some other data from something else just displayed here. And I can insert various visuals here. For example, let's just insert this bar chart. And now this bar chart needs some data. So there is some data sitting here. So let's see, the parts will go on the axis, and the inventory will go on the values. And now I'm displaying a little bar chart. That's the sort of thing you can do in Power BI. Well, a custom visual is like the built-in visuals, but we've just added this one here. And when we click here, so I think it's running that whole extended simulation now, which may take a while for it to come back. But there, okay, it comes back with a display very much like what we had in the desktop version. And actually, we can look at different simulations here. So all that. Now you notice that this is a live model running in Power BI. It is running on fixed data. Now, and what you'd want to do in practice here is to be able to supply new data to this Power BI custom visual and have it run for you. And there are facilities to do that. You go back in Excel and you'd add certain side functions to other cells to point out these are the parameters that I want to supply at runtime when this thing runs, either independently or in Power BI. And then what would happen is you'd have this here, and over on the right here, just as we did for one of these other visuals, you will have it'll ask you for data, and you'll drag and drop it into place, just like I did a moment ago. Okay, so hopefully that's clear enough. So the take-home message is that you can take your model out of desktop Excel and run it as a live model in Power BI, and you could connect it to data that didn't come from Excel, that came from Power BI. Okay, and let me check just a second for questions. Can we use this tool at a wastewater treatment process, build a simulation of the process parameters and their output? Sounds like a good, yes, I would think you could. You need to have the expertise around the wastewater treatment process, and one of the tasks in building a model, first you need to build a model that relates the relevant process parameters to the outputs, and hopefully you have the background to do that. And then you have to also model the uncertainties. You might have uncertainties about the chemical content, I suppose, of the wastewater, or even just the amount of water. That maybe that would also be an uncertain quantity. It would, change over time. And I think that's it. Let's see. I think that's all the questions I have right now. Okay, so we're approaching the top of the hour here. Let's try to summarize a bit. So Analytic Solver, you've seen desktop and cloud versions. You do get both of them when you have a license. Even, by the way, a free trial license gives you access to both of them, desktop and cloud versions. You install the desktop version by running a setup program called Solver Setup, and you install the cloud version in the manner that I was showing by actually going into Excel for the web and choosing Insert Office Add-ins. There's much more here than what we have covered. There's very rich support for data access, various like SQL databases and Spark Big Data clusters. There's a whole facility for forecasting, data mining, text mining, and machine learning that is also included. And that's the subject of another webinar that we conduct periodically. You can obviously do Monte Carlo simulation. Decision trees are actually part of the Monte Carlo simulation capability, and large-scale conventional stochastic optimization, in an area that we haven't had a chance to talk much about yet, but business rules and decision tables also has rather comprehensive coverage. DMN stands for Decision Model and Notation. FIELD stands for Friendly Enough Expression Language, and these are open standards. You can, like if you were to search on DMN or FIELD, you could, DMN is standardized by the Object Management Group, OMG. And then RASON does a whole lot more than what we have covered. It obviously can run models like simulation and optimization models, but it can do a whole lot more than that. It has very rich data connection capabilities. So what's illustrated here is we're hooking up our model online, our model that's going to run in the cloud or run on the web. We're hooking it up to some files on OneDrive. We can hook it up directly to the Microsoft Common Data Service, which underlies Dynamics 365 and also Power Apps. It's used by Power Automate. You can also use more than 100 different data sources through this tool that we have licensed for the CData Cloud Hub. And so in this case, we're actually accessing Google Sheets. You can access Salesforce.com, for example, through CData Cloud Hub. Models are stored on the RASON service or on your own OneDrive. You can maintain model versions, run history, and importantly, you can run multi-stage flows. We'll talk a little bit more about that. There's also there's some strong advantages in terms of information security of using RASON. So here's an example actually of a multi-stage flow. This is a data mining series of operations, but you can also do multi-stage flows of optimization and simulation operations. for example here, starting from a media planning optimization model and going to a next best offer decision, or starting from a crew scheduling model to feed in an app that, like pilots and flight attendants, actually access to learn, what is my rotation today. So all of that is actually available in RASON, and does so in very high performance too. Okay, so in terms of next steps, you can hopefully already visit solver.com, and you can, if you haven't already, you can download a free trial. If you are registered on the site, then you can you can follow any of these paths to get to a free trial. And then you can also visit RASON.com and create a free trial account there and try things out. And you can use these independently or together. So it's perfectly possible to go to RASON.com and just compose it. Like if you read what the syntax is and everything, compose a model and run it yourself. So here's a model that's actually written in the RASON modeling, extended RASON modeling language. It solves a product mix problem. And we could run it, well, here's some results from a previous run. And we could, we could easily enough, we could run it again. Maybe we do need to run it again here. Like that. And there's our results from running this RASON model. So you can do that. And I also do like to recommend for people, if you want to go and learn a lot about RASON quickly, this link, rason.com/help, will open in a browser, and there's very extensive help. You don't even have to have an account or log in or anything. And you can download the PDFs for the RASON user guide and RASON reference guide right there. So there's it's just a whole lot of information here, like setting up simulation model, and here's an example, and all of this is readily available. Okay, so now let's see if in the remaining, we've got 4 minutes until the top of the hour. Let's see if there are any questions that I haven't already answered. GoToWebinar makes these questions quite hard to see. For some reason, they show up in a very tiny area on the screen. Okay. Which distribution? We talked about that. Yes. Industry practices. Yes. Talked about the wastewater problem. I think that's all the questions. So last call for any questions. Please go ahead and type them in. And if not, we will wrap this up. Okay, I think we have answered all the questions. So thank you very much for being with us. I hope you found this interesting, and feel free to follow up with us. And I would recommend following up at consulting@solver.com. I think that's on this slide here. That will reach both Dr. Sima Malecki and me, and we can reply there. And then also, let me just point this out. There's going to be a brief hiatus before we run additional webinars, but if you go to solver.com/webinars, this is Sima Malecki, who ordinarily runs these webinars, you can find our schedule for upcoming webinars. Now, I'll just share this with you. Sima is in the process of moving from the West Coast to the East Coast, and so I'm sort of substituting her for the short term and running the webinars a little less frequently. But if you do watch here, you can see the schedule for upcoming webinars. Now, like here, I think if you say join the next webinar, you're going to find that there's probably there's no dates available yet. But give us a week or two, and we'll have some new webinar dates set. Okay, and with that, again, thank you very much. Have a great day, and we'll wrap up the webinar at this point. Thanks again.